Hi, my name is Ryan Miller. I'm a solutions engineer with CARTO and excited to talk to you today about building agentic experiences going from natural language to geospatial reasoning with PostGIS and Snowflake using the CARTO platform. As I mentioned, I'm a solutions engineer with CARTO, been with CARTO for a little bit more than a year now. Spent my entire career in GIS working for agencies like the Air Force, Department of Energy at a solar startup. And excited to chat with you today about this topic. So as we go through kind of this particular topic, I'm going to kind of use a use case that basically takes us from kind of the business challenge, which is really a really simple question, to kind of a complex answer, and how that complex answer translates into kind of the solution that I've developed for this particular talk, which is leveraging our agentic stack. Which incorporates Snowflake, PostGIS, which are both accessed through CARTO. Briefly talk on the kind of the data processing capability that I went through to kind of prepare the data sets, and then spend a little bit of time on the steps to kind of enable the agent or configure the agent so that it can be used for end users to kind of interact with these different data sources and ask the different types of questions that we'll see. And then conclude with a demonstration, kind of show you what this looks like within CARTO, the types of questions and responses that the agent is able to provide, and kind of show you kind of a hands-on working live demo of this capability. All right, so the simple business question that we're going to kind of tackle today is somebody comes to you and says, hey, I want to be able to find vacant land parcels in California that have between 10 and 20 acres of buildable area that are within a quarter mile of a transmission line. So this could be for a data center project or a renewable energy project. Again, kind of the purpose of this question is kind of provide an example of the types of queries that questions that may get asked, and then ultimately the types of queries that these would transform into. So if we kind of break this down a little bit, like what does this mean technically? So we start thinking about, okay, vacant land parcels in California. Well, California has about 12.5 million land parcels, which consist of different land uses, different land ownerships. So we've got a large parcel data set that we've got to deal with from a processing standpoint. The component about, well, but we want a buildable area. Well, what does that mean? Well, we've got topographic constraints. We've got hydrologic constraints. So think of, can't build too close to a river. We can't, obviously, there's wetland challenges, riparian areas that all need to be factored into a buildable area. And in this particular case, we want to be able to kind of do cross data queries. So parcels within a particular distance of a feature. So it could be a transmission line. It could be really any sort of geometry that we want to bring into our analysis. And then in this particular example, I've got kind of two different databases or data warehouses that we're leveraging. One is Snowflake, which allows us to kind of process the data at scale. We're executing these queries against these large data sets. And then we've got kind of more of a transactional PostGIS, Postgres instance, where we're taking our selected set of parcels, we're saving them into a Postgres instance where maybe we have some downstream operations where whether the commercial real estate organization wants to take those, or the engineering organization wants to take those subset of records and do additional analysis to kind of evaluate them, incorporate them in their kind of processes. So kind of we're focused on this middle ground of using an agent to help kind of filter out these different these parcels based on these constraints that we've talked about here. So we kind of break this down. There's kind of 4 different steps we'll be going through today. First one is on the data processing side. So we've set up a processing pipeline utilizing CARTO workflows, which basically uses a combination of the Snowflake functionality. So out of the box. Snowflake has a geography data type, which we leverage. And then they have kind of a core set of spatial operations and spatial functions. And then CARTO brings their analytics toolbox components, which kind of takes those core sets of components and kind of rounds out the toolbox of features to allow you to have a more robust set of capabilities to allow you to have kind of a full set of spatial operators. Talk a little bit about the infrastructure or the CARTO instance that I created. So basically, it's a builder map that is connected to both a Snowflake data warehouse and a PostGIS instance, kind of allow you to have this dynamic interaction between both data resources and allows you to kind of move subsets of records between them. In the types of questions that we're going to answer, we've got to have multiple layers. We don't know kind of the distances or the different types of questions that the end user is going to want to ask. So whether it's a distance from transmission lines, power lines, really any sort of feature that we've added to the map, we've got those in this particular examples, but we want to be sure that those tables are optimized so that spatial queries can perform efficiently. We'll talk quite a bit about kind of the agent builder process. So how do we build the agent, which is embedded in our builder application, our map-based application, and we need to educate the agent on the types of interactions and give it instructions on how to perform kind of some of the core sets of use cases that we're going to enable through CARTO. All right, so a little bit on the processing pipeline. This is a schematic of our workflow environment that kind of allows you to build out these geospatial data processing activities. So we've got kind of our data sources on the left. So those would be things like, as we mentioned, parcels, topography, hydrography, streamlines, riparian areas, etc. And we're doing different sorts of operations like buffers, filtering out maybe based on attributes, and then we're basically differencing them. So we've got our parcels, we're subtracting out those streamed buffers, the areas that exceed certain slopes, etc., and saving a end result data set that kind of has these constraints removed. That would be our buildable areas in this particular example. This process all operates on Snowflake. It's fairly efficient. A complex set of operations like this on 12 million parcels with an extra large Snowflake data set takes about 45 minutes. So relatively speaking, that's pretty efficient, pretty quick. Allows you to execute these large scale geospatial capabilities very efficiently. All right, so we start thinking about kind of the infrastructure in this particular example. So as I mentioned, we've got kind of two different data resources. Postgres, where this acts in this particular demo as a persistent system of record for production. And so we take those saved results, and maybe there's some downstream processes that leverage those parcels for other activities. So it really kind of stores what the agent finds, making them available for other types of applications. And then on the Snowflake side, this is where we're really kind of processing the data at scale, utilizing kind of some standard geospatial functions within area where these are operating via the queries generated by the agent, where it will filter the records based on both the attributes that are part of the source data, or looking across different layers to kind of do those kind of spatial joins, spatial queries. And these are both accessed through CARTO's builder map, which basically provides you kind of one interface to multiple data sources to kind of implement and execute these types of operations kind of through a single agent interface. So the types of examples in this is types of layers, again, that we're going to show here. There's really kind of we've got our source data, which is the parcel layers, like as I mentioned, about 12.5 million parcels. But then we start to bring in these other features and layers that we want the agent to be able to reference. So in the particular question that we started with, well, we're going to need where those electrical lines are, and then we're going to have some sort of distance. Obviously, these could be any type of geometries that would want to bring into the analysis, but basically allows you to perform these kind of cross table queries that allow you to kind of filter out records based on the different geometries. So now let's spend a little bit of time talking about kind of the agent and kind of which data source they operate against. So we think about things like the distance or these kind of cross-tabular execution. So those will be performed in Snowflake. So I have both the parcel data sets and then the other geometries, whether they're the lines from the transmission lines, the points from the power generation facilities, substations. So we allow you to kind of do those types of queries across table. Similarly, the straight attribute queries where we're executing a where clause or the agent's executing a where clause based on the particular properties of those polygons and filtering out those kind of on the fly. And then we talk about the saving of the parcel. So we found a subset of parcels, and we want to keep those and move those over to a permanent set of records. And that's where we're basically querying from Snowflake and moving those over to Postgres, where we can do different types of analyses. And then once we have those in Postgres, the agent can interact with those parcel polygons inside of Postgres, give me a summary, give me details about individual parcels, show those on the map. All of those capabilities can happen inside of Builder. Again, so the end user is leveraging kind of both of these environments seamlessly. I actually added some context to let the end user know what's going on in what data warehouse for demo purposes, but really kind of leveraging the capability of both systems efficiently and kind of behind the scenes or invisible to the end user. So when we think about how do we develop an agent, it's kind of like prompt engineering using a map. So it's got a number of different components. First one is kind of the agent configuration, right? So these are the types of experiences, steps, boundaries that you apply that tell the agent basically, here is what we want you to do, or importantly, what we don't want you to do, how we want you to do it, etc. Also have the ability to bring in tools, and I'll talk a little bit about that in the next couple of slides. And kind of these are the capabilities that the agent has access to do different types of operations, and those could be both spatial or non-spatial operations. Obviously, we've got a model that needs to be accessed. So this is where you'd say, which model do we want to leverage through this process, and then the types of prompts to get started. So maybe give the end user a little bit of background. Here's a good place to start. Kind of how do you get going with the interaction with the end user, and we'll see that here in a second. Kind of drilling down a little bit, kind of the tools that the agent has access to kind of fall into two primary categories. The first one would be kind of data processing tools. So the agent has access to workflows and queries to the connected data sources. So as you're configuring the agent, you're adding the data sources, you're telling the agent, okay, you can query these data sources or not. And it can do powerful tasks like data enrichment, statistical aggregation, those types of activities. And then we think about like user interaction tools. So this is how you collect input from the user. So that could be drawing a mask on the map to say focus on this particular area, or use kind of contextual information like save the parcels that I'm looking at, which would then basically the agent would be able to reconcile that description and say, okay, I'm going to use the area viewport or the area of the map extent to process and save those answers. So really kind of tying kind of the contextual information and the geospatial reasoning that the agent is able to perform to kind of give the end user the experience that they're looking for. Talk a little bit about server-side tools and MCP tools. So you can define kind of these geospatial processes that the end user or the developer defines. So you're ensuring that the agent has access to kind of consistent, controlled processes and outputs for the information that the agent is going to communicate to the end user. So particular examples around site selection, data enrichment, risk assessment, again, leveraging these workflows, exposing them as MCP tools, and then access by the agent. The agent can also dynamically generate SQL using these connected data sources. So this is what we'll see today, kind of on-the-fly filtering, giving me summaries, computing averages, applying different types of spatial filters. A lot of capabilities here that the agent has the ability to formulate these queries, execute these queries, and kind of give the user that experience of doing some sort of spatial analysis with not really understanding a lot of the complexities behind the scene. Briefly, MCP tools as workflows. So workflows, what you're looking at in the background there, these are components that allow you to kind of string together processes. You build out these processes as kind of you define. So this is exactly the series of steps that you want this process to implement. You publish these workflows as MCP tools. Then over on your agent, you say, okay, when you're going to do this particular activity, you need to use this particular workflow. So then the agent has passes the required information to the workflow. The workflow is executed. It generates a set of results, which then go back to the agent, and the agent would return the series of answers or data driven directly from the process that pretty powerful capability that allows a little bit more control over how the agent generates the answers that it's ultimately telling the end users. These tools that the agent has access to kind of allow you to capture input. So they kind of capture the inputs from the users and then present the outputs back to the users. So collect inputs, as we talked about, whether it's a region on mask, capturing pass-in coordinates, pass an address, and does some sort of geocoding. But then once it does the process, as you'll see here in a few moments, kind of takes those outputs, adds those back to the map and styles them so that you get kind of a subset of results, and then what you can use for kind of further processing. Yeah, so a lot of capability and interactivity that you have. You can, the agent says, here's the results, and it's in a color that you don't like. You can say, okay, can you recolor those to, instead of maybe blue, I want those as yellow. Agent has the capability to kind of interact with the data that's rendered on the map, and a lot of flexibility there. All right, so now the fun part. Let's jump into a brief demonstration of kind of what I built, and kind of show you kind of how this looks. All right, so let me stop presenting that. All right. What we're looking at here is our Builder application. Builder allows you to take data from the data warehouse and visualize it on the map. So in this particular case, we've got data that we're looking at from both Snowflake and PostGIS, and presenting those data spatially. But then also on the right-hand side, we have different types of widgets that you can add to allow you to filter those attributes of those data and kind of have an interactive dashboard. All right, so the first thing I want to do is kind of show you kind of that constraints activity or constraints process that we implemented. So let me kind of zoom in here. Let me make a little bit more space. add in our constraints for our slope layer. Let me look right along the fringe here, and then add in our hydrography data sources, and then our suitable parcels data sources. So as I zoom in here, these layers will start to appear and basically allow us to kind of see kind of the interaction between these different data sets. So we've got, as I mentioned, our slope constraints. We've got our hydrography constraints, which are wetlands, distance from rivers and riparian areas. And then we have our parcels constraints. And so if we kind of look at how these three sources interact, you can see our blue areas are hydrography constraints. And then we've kind of removed those non-buildable areas out of our parcel. So basically, after running that process that we went through, we're only left with the portions of the parcels that are buildable. So that's kind of the starting point that we're using in our agentic sets of activities. All right, so let me kind of zoom out, kind of reset the map, and then we'll start our agent interactions. All right, so if this is basically how you access the agent. We'll start with the basic question of what can you do? And so basically using the instructions that I provided to the agent, it will tell us the types of activities that it can do. So it can find parcels based on different sets of criteria, and then also it can save parcels. So once we found the parcels that we're interested in, we want to save those, in this particular case, to Postgres. It can do that as well. So I'm going to follow up with the question that we had in our presentation. So basically, find me the land parcels in California that have a buildable area between 10 and 20 acres that are within a quarter mile of a transmission line. And so this is going to formulate and execute the query, but before it's going to ask if I want to further filter based on the market value. And I'll just say include all parcels. So it's going to formulate the query using the parcel data set and then that quarter mile distance of these transmission lines over the state of California. Take those results, add those results to the map, and then style them and zoom the map to that particular location. All right, so it found 2,250 parcels that match this criteria. And so up over here on the right, we should start to see a new layer appear, and you can see where it will style it. So yep, here's our vacant land parcels. It added it, so now it's going to style it. It colored them red. And then it will zoom the map to kind of the maximum extent of the data set. And now it should give me a result based on the market value. So kind of give you a short summary along with adding those records onto the map. All right, well, I want to further kind of drill into this set of data to identify just those parcels that are in San Bernardino. So let me ask it, do you have any parcels in San Bernardino? And so basically what it's doing, it's taking these 2,000 plus parcels, executing an attribute filter, so where the parcel has an address that contains San Bernardino, and hopefully it will find a set of records that it will then add to the map, style, and zoom into. All right, so it says, yes, I found 17 parcels. And so basically it removed the previous set of results, and now it's adding just these 17 parcels to the map based on those parcels that are inside of San Bernardino. So you can see up here on the right, it's saying, okay, we found vacant land parcels in San Bernardino. It's adding them, zooming to the map, zooming in. Let me turn off our slope constraints layer. And basically said, okay, here's the top 5 parcels based off of different types of criteria. All right, so we can see a few, let me turn this off a little bit easier to see, a few different sets of parcels around. There should be 17. Let me focus on this kind of cluster of 3 parcels here. So basically, we've got different tooltips that you can tell the agent to add, the different types of interactions we want. And so now we've got these parcels, and we want to save them to our PostGIS database. Again, everything so far has been processed inside of Snowflake. So before I ask the agent, let me just make sure that my parcels table is empty. It is. All right, so let me say, can you save the parcels I'm looking at on the map? And the way I've set up the agent is to, okay, before we save, let's add some sort of note or context about these particular locations, and follow up with these owners. All right. So basically what the agent is going to do at this point is going to say, okay, well, it's actually not 17, but it should just be the 3. So basically what it's going to do is take the map extent and do a filter based off of the map extent and say, okay, let me get this subset of records and query the attributes from Snowflake, and then move those records into the Postgres instance using Snowflake. Actually, I've identified the 3 that are visible on the map. Now each of them will be selected and then saved. It just take a minute. So it's basically going to iterate and say, okay, so I've successfully saved this parcel and then the other ones as well. It can say, do we want to add those back? Let me go and just confirm that that's exactly what it did. Yep, here's our 3 different parcels that it added. And let me ask it questions about the save parcels now. So this will be executing queries directly against Postgres. How many parcels do we have saved? And so it should tell me that we have 3 saved. And so again, you can kind of see where you've got these different data sources in play, where you can kind of share them. The agent can have access to both data resources for its particular use cases. So one last question: can you show me these? And so basically, this will query the Postgres database, add those parcels to the map, style them just like it did before. So this would be just those 3 that we have saved inside of Postgres. So hopefully this gives you kind of an understanding of what this looks like. Slides gave you a little bit of background along with kind of the live demo. Happy to take any sorts of questions you have about the way that I've set this up. Thank you.